Hello everyone, this lesson is going to talk about the atomic structure and interatomic bondings. And this is the part ones for this lessons. So the learning objective of this lessons for the past ones is that we are going to study about the atomic model. There are two different atomic model and the difference between these atomic model. And the second objectives for this part ones lesson is that the importance of quantum mechanical principle, they related with the electron energy, and I will going to talk a little bit more about the elements arranged in the periodic table and how these elements arranged in the periodic table. Okay, let's start it. So the atomic structure. So the atomic structure that we have to see about the structure of the atoms. So in the atoms, there will be the nucleus, which is at the center, as you can see in here, okay, at the center. So in that nucleus, there will be the protons and the neutrons. So protons have a positive charge, okay, they have a positive charge. And around this nucleus, there will be the electrons. The electrons are orbiting around the nucleus. So these electrons have a negative charge. They are orbiting of the orbit of these electrons. So to describe about the atomic structure in such a way to write down in forms, so we have the element with the symbol of X, okay, the clock structure. So this is the atomic symbol. So this is the abbreviations that's used to describe about what kind of elements, okay, what kind of element is that. So that represents the atomic number, which is the number of the proton. And the number of proton is very important because the number of proton is the identity number of the elements. You have your own identity number, just like this. The element have their own identity number. So number of protons in this atom, in this particular atom of the element, it represents, okay, the identity of this element, but the identity of this atom, the identity of this element. So this is that, okay. Another one is A with the symbol H, which is the mass number, which is the sum of number of proton and number of neutrons in the atom. So this is the mass number. So let's see the example. So this is the carbon atom. I already explained before. There will be the nucleus at the center, which is the protons and the neutrons. Okay, neutrons. So I forgot to explain one thing. The neutrons have a neutral charge. They don't have a negative charge. They don't have a positive charge. They have neither of positive and negative charge. They have a neutral charge. Okay. So, and then the electrons are orbiting around this atom. So the carbons have its own identity number, which is 6. This is the number of the protons. And this is the symbol of the carbons with the C letter. And this one is the number of protons and the number of neutrons. So the carbons in the nucleus, they have a 6 neutron and 6 protons. So this is the element of the carbon. Okay. So next we need to understand about the isotopes. So what is the isotopes? The isotopes is the atoms of some elements, they have 2 or more different atomic masses, which are called the isotopes. That means they have the same elements. For example, this is the carbons, okay? Carbon, they have the 6 proton, okay? This carbon have a 6 proton, and this carbon has a 6 proton. This is the carbon, but the difference is number of neutrons. So this one have the 6 neutrons, so the total is the 12. But this carbon have 7 neutron, so the total is the 13. So this difference of the number of the neutron, but the same proton number, it is called the isotopes or the elements. So this one is called the carbon 12 because the 6 proton plus 6 neutron 12, but this one is a 6 proton plus 7 neutron, you call it carbon 13. So two different isotopes, but it's more than two different isotopes. Carbon is about 3 isotopes, but it could be 4 isotopes. But the more abundant carbons, isotopes carbon are the carbon 12 and carbon 13. Okay, next, now so far we understand about the atoms. They have the protons and neutrons in the nucleus, the electrons orbiting around the nucleus. So what we had been so far understand is the Bohr theory model, Bohr theory model of the atoms. Okay. So in the Bohr theory model, the atoms, the electrons have a discrete energy. They have their own orbital. They have to orbit in their own orbital, and there will be the proton and neutrons at the center, the nucleus. And the wave mechanical model, the nature of the electrons orbiting around the nucleus is different. It's because these electrons have a wave-like nature and also the particle-like nature too. They have quantum energy. The electrons are orbiting around specific defined energy level, and also these electrons are quantized. So this is a difference. But let's make it more clearly how we already apply this wave mechanical models, quantum theory, into our theoretical explanation about material, the property, especially in electronic property. So for this figure, okay, the A is the Bohr's theory model, B is a wave mechanical model. In the Bohr theory model, there will be the energy of these electrons internal the electron both, okay, and they have only one discrete energy, okay. But in the wave mechanical model, the electron energy of the electron are quantized. That means they have more specified energy. For example, when you're gonna see clearly in the higher shell of orbiting electrons around the nucleus, there will be two different quantum energy, 2s and 2p, and the higher ones, there will be three different ones with 3s, 3p, and 3d. So this is a how difference, how we already apply the wave mechanical model. Another one, as I already mentioned, right? If the electrons are orbiting one discrete energy, okay, they have their own defined orbiting energy state in the Bohr theory model. But in the wave mechanical model, the electrons are wave-like nature, and also the positions is not just one particular. It is the probability of electron distributions. They have the higher chance of the electron that could be in this particular path of the orbiting electrons, but there will be the probability of the other path that the electron could orbit. So we define the position of electrons internal the probability in the wave mechanical model. So this is the difference between the Bohr theory model and the wave mechanical model of the atomic structure. So then there will be the different quantum number. There will be mainly 4 quantum number, okay? Specifically for quantum number. So the first one is the spin quantum number. The second one number is the azimuth quantum number, and the last one is magnetic quantum number, and the fourth one is spin quantum number. Okay, let's start with the first one, which is the principal quantum number, representing with the nth small letter. So it determines the size of the shell. That means the size of the atoms in which a particular electron orbits around the nucleus and energy. So because the electrons are orbiting around the nucleus internal of the shell, okay, the shell, the main shell. So the higher the number of electrons orbiting around the nucleus, the higher the number of the shell of its atom, so the size will be bigger. So that's why this principal number it's controlling, it's determining the size of the shell, the size of the atoms. So we have K shell, allen shell, M shell, 1, 2, 3. So okay, if n equal 1, so this is a K shell. So this is the first shell of this one, and the second shell will be allen shell, and that's one shell will be the M shell. So this is the shell, the number of shell in the atoms. So this is the principal quantum number determining the size. So this is 6 carbon. There will be only 6 electrons orbiting around the nucleus, but unions is 92. This is a different side of the atoms, union, and carbon, right? The side much different because the number of electrons orbiting around the nucleus in the unions have a large number of electrons than compared with the carbons. So the second quantum number is the azimuthal quantum number. It is also called the angular momentum quantum number. Okay, so this quantum number specifies and determines the shape of the orbital. How this define the shape of the orbital is that, so it's the value of the L is 0, which means as orbital, if the value of the L is 1, it means the p orbital. It does mean like the outer shell of this atom is like a p orbital. If the velocity, the outer shell, the electrons is d orbital and f orbital, etc. Okay, so for the f orbital, so there will be like electron are in the nature of the spherical shapes, like the electron orbiting in a circular motion. Okay, but in the p orbital, the p orbital have a 3 different direction, like in the direction x, in the direction y, in the direction z. So they have a different direction. Depending on the different directions, so they have a parabolic nature of the electron orbiting around the nucleus. So that's why this azimuthal quantum number is defining the shapes of the atoms. So which is the subshell of the atoms. Okay, that's quantum number is the magnetic quantum number. This control the number of along spatial orientations, that which called the degeneracy of each orbital, which can be specified by the M. Okay, so this magnetic quantum number could be 0 in the up shell, and it could be plus or minus 1 in the p shell, and it could be plus 2 plus 1 0 minus 1 and plus 2 minus 2 in the d shell. Okay, this magnetic quantum number, it's highly influenced to determining the property of the magnetic property, especially in the orbital magnetic moments. And that's one. That's one. And the fourth one is the spin quantum number. So the spin quantum number is determine the electron spins. Not electron is electron spins. So electron spin, they have only just 2 up and downs. So internal number plus 1 divided by 1/2 or minus negative 1 by half. So they have the F spins and the down spins. So this spin quantum number also determines the magnetic property of the material, but in the different principle. It is governed by the spin magnetic moments. So magnetic quantum number, it influences to the magnetic property of the material by means of the orbital magnetic moments, but spin quantum number influence the magnetic property of the material by means of spin magnetic moments. So this is the 4 different quantum number that we already explained, but one theory that we need to keep in mind is that Pauli execution principle. So this principle stated that there is no 2 electrons at the same quantum number within any atoms. So no more than 2 electrons in the same quantum number. There will be only 2 maximums in the same quantum number. Okay, so this is generally about the quantum number to understand about the with mechanical model of the atoms. And then next, let's go to the electron configuration. So the electron configuration is mostly basically based on the principal quantum number and azimuthal quantum number. So shell and the subshell of the atom. So this figure, so on this horizontal line, there will be the principal quantum number, which is the 1, 2, 3, 4, 5, 6, 7. And this is the energy of the electron that's orbiting around the nucleus. So in the first principal quantum number n equal 1, there will be only S subshell. But in the second quantum number n equal 2, there will be 2 subshell, which is the up shell and the p shell. And thus in quantum number 3, there will be S shell, p shell, and d shell. But there will be one thing that we need to understand. But here, the S shell is lower energy level than D shell. So in this case, we are not going to the D shell before we free off the electrons in the S shell. Okay, when we take a look in this table, then you will see here. Okay, so in the potassiums, first we came with the S1s2, 2s2, 2b6, and 3s2, and 3b6. This is the 3 pieces. After 3 pieces, it's not going to 3D, but it's going to the 4s1s. So it's easy 4s1 and 4s2. After the electron is fade into 4s orbital, and then is go back to the 3D ones and then 3D two. So this kind of concept is based on the offer principle. Okay, but I'm not going to talk more about the offer principle, but this kind of principle have to apply when you are trying to understand the electron configuration, how the electron are free in the orbital around the nucleus of the atoms. Okay, so next, the periodic table. That's very important. So the electrons and proton and neutrons in the atoms, and because of the one identity number of the atoms by the proton number, and according to this proton number, the element arranged in this periodic table. For example, 1s hydrogens, 2 heliums, 3 lithium, 4 berylliums, 5 borons, 6 carbons, 7 nitrogen, 8 oxygens. And these are the proton number. That means these are the identity number of these elements. And bind this identity number, bind this proton number, the atom are arranged in this periodic table. Okay. So the elements have a group and group 1A and group 2A. So this is the columns and this is the row. Okay. At the same columns have a similar balanced electrons, balanced electron structure, as well as chemical property and physical property. So at the columns, the same and similar balanced electron and the similar electrical ends are physical property, chemical property. And it's changed gradually and horizontally from right to left and left to right. So this is how the elements are arranged in this periodic table. And let's take a look one example how they arrange. So we have to know about the electropositive elements and electronegative elements. So electropositive elements, that means these elements are willing to give us the electrons, willing to give the their electrons to the other surrounded electrons. The other surrounded the atoms, and they became a positive charge because they give the electron, so they became a positive charge. But the electronegative, that means the elements, the atom, they want to absorb the electrons, so that means they became a negative charge. Okay, so electronegativity means they have the tendency that they are willing to absorb the electrons. So when you take a look at this periodic table, when you can see the arranged by the electronegativity value. So the fluorines have the highest electronegativity value, which is a number of 4.1. So see this how the periodic table are arranged by means of chemical property and physical property, and and also by means of this identity number by the number of the protons in the nucleus. So this is everything that's above for the first part of the atomic structure. Now we study about the atomic model, both theory model and wave mechanical model, and the difference between these two models, and more into about the quantum number, that's explaining about wave mechanical model, and also a little bit about arrangement of the elements in the periodic table, and also how the groups and then the row in the periodic table have similar mechanical and chemical property. So this is the first one, the part one of these lessons, and we will see you again in the part 2 of the atomic structure and interatomic bonding. In the part 2, I'm going to talk about the interatomic bondings between the atoms. See you guys.